Okay, let's talk about the planarity testing algorithm now. I'm not going to go into every single detail of this algorithm. You can read this out, but what I'm going to do is to work on an example graph. So here is our graph in question. We want to find out whether this graph with 8 nodes is planar or not. We will name this graph as G, or maybe G0. And then we will go step by step, just by starting with a cycle. Here is just one cycle. You can choose any cycle you want in a planarity testing algorithm. It really doesn't matter where you start. You just need one cycle. And here in this example, I chose the cycle of 1, 6, 5, 4, 3, 2, 1. Or you can go the other side. So 1, 2, 3, 4, 5, 6, 1. So here is our cycle, and here is a clean drawing of that cycle. Let's call this G1. This is a subgraph of the original one that is shown in red in the upper figure. So once we identify a cycle, that's where our algorithms start. As you can see in the first line, find a circuit or a cycle C of graph G. Then we have some initialization steps. Then the main loop of the algorithm is in this while loop. And then it goes on and on in iterations until the whole graph is drawn in a planar way. Or if the graph is not planar, this algorithm will tell you at some point that G is not planar. So how does it do that? Once we have a cycle, we start, and I draw this table here to show how the algorithm proceeds. We will name the faces of this cycle G1. So as you remember, in planar graphs, we can identify the faces of a graph, and let's call the exterior face as F1 and the interior face as F2. After identifying the faces, now let's find out the bridges of the original graph with respect to the cycle G1. Here is a bridge, the edge between 1 and 3. And let's call that bridge B1. Here is another bridge that starts with the edge between 3 and 5, 5, 8, 8, 7, 7, 6, 7, 5, 7, 2, and 8, 2. This is a very large component, which is a bridge, and it is shown here as B5. The other bridges are 3, 5, 1, 4, and 4, 6. So we have 5 different bridges. The next thing to look at is to find out which faces we can draw these bridges. For example, let's look at a simple one, bridge 1, 3. This is actually it's just a single edge between nodes 1 and 3. And we can draw that edge here on face 2 or on the exterior face around like this. So both of these options are possible. That's why we put here both of the faces, F1 and F2. So this is a set of faces in which we can draw the bridge without crossing edges. So there are 2 options for bridge 1 to draw. For B2, and actually for all other bridges, we will do the same thing. We will check which faces are feasible for this bridge. For B3, for example, let's take B3. It's an edge between 3 and 5. It's just a single edge. We can draw it here or from outside. The largest one, B5, is composed of 1, 2, 3, 4, 5, 6 different edges. You can try this for yourself, but you will find out that it is possible to draw this bridge either on phase 2 or phase 1, doesn't matter. So we have two options for that bridge as well. After identifying all these sets, the next thing to do in the algorithm, and let me just go back. Find each bridge B of the graph relative to G1 for Gi in each iteration. For each bridge, find the set of feasible faces. And then if for some bridges, this set is an empty set, then it means that we cannot draw that bridge as a planar part of the graph, which means the graph is not embeddable on plane, which also means that this graph is not planar, and at that point the algorithm will stop. Otherwise, if all bridges are embeddable on some face, then we continue from this point. If for some bridge the number of elements in the set is equal to 1, then we choose that bridge. Otherwise, we can choose any bridge we want. So going back to this example, now after identifying all the faces, we need to make a choice. We will choose one of the bridges. And since all of them are embeddable on both of the faces, we can choose randomly one of those bridges. Let's choose bridge 1. Bridge 1 was the edge 1, 3. So we are choosing bridge 1, and after choosing the bridge 1, we have to choose a face to draw that bridge. Let's choose F1, which is the exterior edge. So we will draw the edge from 1 to 3 like this. And this will actually create a path. Why we call this a path is actually visible for larger bridges. If the bridge is composed of only one edge, then the edge itself is a path. And that's the end of the first iteration. As you can see, by adding the edge between 1 and 3, we created a second graph, which we call G2. Now, this is no longer a single cycle, but it's actually another subgraph of the upper graph here that we created by adding one of the bridges to G1. So now we are working on G2. And then we will repeat the iteration of the algorithm once again, this time taking into account G2 instead of G1. So our starting subgraph will be G2. And of course, by adding this edge, we created another face, a third face. That third phase was created by dividing F1 into two different regions or two different phases. So let's name these two different phases F3 and F4 so that we don't confuse it with F1. We won't use the name F1 anymore. So we have three phases, F2, F3, and F4. And then we identify the bridges with respect to the original graph. and those are B2, B3, B4, B5. You can verify that they are the same bridges. But then the faces that we can draw these bridges on have changed names because they have to be identified once again by looking at the new graph. For example, B2, bridge B2, the edge between 1 and 4 can be drawn on F2 and F3. 1 to 4 can go like this, or it can be drawn like this. There's no way to draw this edge on face 4. As you can see, we will need to cross an edge, which we don't want to do. So once again, you have to identify each of these faces for each of the bridges. And then the algorithm goes on choosing the next bridge to draw on G2. From this point on, I want you to continue this example and find out how it works through the other iterations. You can use the algorithm description in the previous slides as your guideline. So go ahead and complete this example.